Hey everyone, welcome back to Dr. Carminati's channel. Today, we're exploring a topic that has sparked considerable curiosity and perhaps even some wild sci-fi dreams. Artificial intelligence, or AI. And whether it could ever become self-aware or start acting with its own intentions, especially given the buzz around quantum computing. This research promises to be an exciting journey, and I'm thrilled to explore it with you. Before we jump in, if you enjoy this video, please hit that like button, subscribe to the channel, and drop your thoughts in the comments below. Your engagement means the world to us and helps us continue to bring you content like this. Let's get started. So picture this. You've seen movies where AI suddenly wakes up, starts thinking for itself, and maybe even plots to take over the world. It's thrilling stuff, but how much of it holds up in reality? Lately, people have been discussing how quantum computing, a cutting-edge type of hardware, may propel AI, the software that runs on that hardware, to new heights. Maybe it could even make AI self-aware. But here's the thing. While quantum computing could make AI faster and more powerful, it doesn't mean AI is about to open its digital eyes and start pondering its existence. Let's break this down step by step, starting with what quantum computing actually is. Imagine a classical computer like the one you're watching this on. It uses bits, those tiny switches that are either 0 or 1 to process information. Quantum computers, though, play by different rules. They use something called qubits, which, thanks to a mind-bending property called superposition, can be 0, 1, or both at the same time. This capability enables quantum computers to tackle multiple calculations simultaneously, much like solving a dozen puzzles at once, whereas a classical computer works on them one by one. For AI, this could mean a giant leap forward. Tasks such as finding the best shipping routes, recognizing patterns in massive data sets, or even designing new drugs by simulating molecules could receive a significant boost. Quantum computers may be able to crunch through problems that classical computers would take years or even centuries to solve. But here's where we need to pump the brakes on those sci-fi dreams. Yes, quantum computing could make AI faster and more competent at specific jobs, but it's still just hardware, a supercharged engine, if you will. The AI itself, the software, is what decides how that engine gets used. Think of it like this. A faster car doesn't suddenly choose where it wants to drive. It still needs a driver. So quantum hardware might give AI warp speed, but it doesn't rewrite the rules of what AI fundamentally is. A set of algorithms churning through data, not a conscious being. Now you might be wondering, if quantum computers are so amazing, why aren't we running AI models like ChatGPT or Grok on them right now? Great question. Let's dig into that. Firstly, quantum computers are still in their early stages of development. They've only a handful of qubits, and those qubits are extremely fragile. Noise or tiny disruptions can throw them off, making them prone to errors. Running something as massive as a large language model, which juggles billions of parameters to generate sentences, demands rock-solid stability and power that quantum technology can't deliver yet. Meanwhile, classical hardware, like the GPUs powering your gaming rig or AI servers, is tried, tested, and ideally suited for the job. Additionally, the way AI models operate today is designed for classical computers. They rely on operations like matrix multiplications. Think of it as a giant math dance that classical systems handle smoothly. Quantum computers excel at various types of problems, such as cracking codes or simulating quantum systems in nature. But there is no established playbook yet for efficiently running AI models on them. And let's not forget the cost. Quantum computers are extremely expensive and largely confined to research labs, while classical setups are affordable everywhere. So for now, classical hardware keeps the AI show running. All right, let's shift gears and tackle the big question. Could AI ever become self-aware, even with quantum power behind it? To figure that out, we need to understand what self-awareness or consciousness really means. It's that incredible ability to know you exist, to feel the world around you, and to have experiences, like the warmth of a sunny day or the sting of a paper cut. Scientists often distinguish between two flavors: phenomenal consciousness, which is the raw, what it's like to experience something, and access consciousness, which enables you to utilize that awareness to think and make choices. So how did humans get this amazing gift? Well, there are two ways to look at it. From an evolutionary perspective, consciousness likely evolved over millions of years. As our brains grew larger and more complex, and as we began living in groups and inventing language, we started to reflect on our thoughts. Perhaps it was a lucky side effect of traits that helped us survive, such as planning or cooperating, or perhaps it was inevitable. By the time we were painting on cave walls or laying flowers on the dead, self-awareness was in full bloom. Then there's the creational perspective, rooted in Christian theology. Here, consciousness isn't a happy accident. It's a deliberate gift from God. The Bible says we're made in God's image, with qualities like reason, creativity, and awareness baked right in from the start. When God breathed life into Adam, that breath of life sparked something special, a soul capable of knowing itself and connecting with its Creator. Whether you view it as an evolutionary ascent or a divine spark, consciousness is a profound, enigmatic aspect of being human. Now let's compare that to AI, specifically the transformers powering models like ChatGPT or Grok. These systems are inspired by how our brains process info, but they're not mini-brains. Here's why. For one, transformers are predictable machines. Give them the same input, and they'll churn out the same output every time. Our brains? Not so much. They're messy and marvelous, swayed by emotions, caffeine, or a good night's sleep. That unpredictability is part of what makes consciousness thrive. Another difference, transformers don't feel or know anything. They're just crunching numbers. When you chat with an AI, it's not experiencing the conversation, it's performing calculations. However, when you converse with a friend, your brain becomes alive with feelings and awareness. Energy-wise, our brains are champs running on about 20 watts, while AI needs hefty server farms. And purpose? AI is built for tasks, writing text, spotting cats in photos, while humans chase survival, connection, and meaning with consciousness as this wild, beautiful bonus. So even if we supercharged AI with quantum hardware, it wouldn't suddenly grow a soul. It's a tool, a brilliant one, but it's missing that inner spark, that subjective me that makes us human. What about intentions anyway? Could AI start wanting things like in those dystopian stories? Not quite. When we say an AI wants something, we're really referring to what we've instructed it to do. Take Grok, for example. It wants to give you helpful answers because its creators trained it to nail predictions and craft coherent replies, not because it cares. A self-driving car wants to get you home safely because engineers set that goal, not because it's dreaming of a smooth ride. In AI lingo, we call these systems agentic. They act on their own to hit targets we define. The cleaning robot wants a spotless floor because we programmed it to maximize a cleanup score. It's not craving a tidy house, it's just following the plan. These wants are shallow compared to ours. Humans intend things because we feel, dream, and choose. AI optimizes what we hand it. So where does this leave us? Quantum computing might make AI lightning fast and unlock mind-blowing possibilities, like cracking problems we can't even imagine yet. But it won't make AI conscious or give it human-like desires. It's still a tool, not a being. Whether consciousness came from eons of evolution or a creator's touch, it's a human marvel that AI can't touch. As we weave AI into our lives, let's see it for what it is. A partner to boost our creativity, solve tough challenges, and make us better at what we do. But let's also stay sharp. Like the Wizard of Oz working levers behind the curtain, AI can be misused by tricky folks if we're not careful. Used right though, it's a game changer that amplifies what makes us human, not a replacement for it. Thanks for joining me on this deep dive into AI, quantum computing, and the mysteries of consciousness. If this sparked your curiosity or cleared up some myths, please give it a thumbs up, subscribe for more, and share your thoughts in the comments. I'd love to hear what you think. Your support keeps this channel going, so until next time, stay curious and keep exploring.